Welcome back. So now we are gonna be continuing our discussion about Parkinson's disease. So, last recording, or last video, I talked about the etiologies of Parkinson's, and there's not really an absolute cause of what really brings about this disease. So, I'm gonna go over this theory that is one of the more popular theories that could explain Parkinson's disease, the oxidative stress theory. It's like the gate control theory if you've watched the other videos. Okay, so let's go. Oxidative stress theory. The oxidative stress theory, which is also known as the free radical theory of aging, but I prefer the shorter title, suggests that aging and many chronic diseases are caused by the cumulative damage inflicted on cells by highly reactive molecules called free radicals. With OST, it usually has an increased amount of iron and aluminum and a decrease in the compensatory rise in isoferritins and glutathione levels. Glutathione is one of the major intracellular antioxidants for quenching reactive oxygen species. So what the hell did I just say? That was just a bunch of words that didn't really make sense, right? So let's go over here. This is the big book. I'm gonna go over this slowly. So here are three concepts that I want to focus on so that we can explain what is OST. First, the Fenton reaction. So we have dopamine, right? Parkinson's disease is all about dopamine. You keep hearing the word dopamine. Dopamine can be inhibitory and excitatory. And usually, when we metabolize dopamine, when we use dopamine, or when the brain uses dopamine, quote unquote, it can lead to a byproduct, right? Everything leads to a byproduct in the body, and chemical reactions always have a byproduct. And for dopamine, it's hydrogen peroxide, H2O2. Crazy. So in a healthy brain, usually hydrogen peroxide is can be neutralized. However, in unhealthy brains, like patients with Parkinson's disease, this byproduct is not capable of being neutralized. So what happens? What happens when we can't neutralize this byproduct? So for example, in Parkinson's, usually you have an increased amount of iron. And if you know iron and the relationship it has with hydrogen peroxide, it is a catalyst. That means when iron comes into contact with hydrogen peroxide, it could lead to the production of hydroxyl radical, which is a free radical. And free radicals, as I've mentioned earlier, are highly reactive molecules that can cause damage. So think of it as like a match and a matchbox. So a matchstick and a matchbox. So the matchbox could be hydrogen peroxide and the matchstick could be the levels of iron. So the higher your levels of iron are, and you slide it over the matchbox, which is hydrogen peroxide, you produce hydroxyl radical, which can create fire. Not literally, okay, not literally. The patient is not setting themselves on fire. I'm just using an analogy so it makes more sense. But the big point here is that this free radical is very dangerous. So that's what we call the Fenton reaction. That's what is related to oxidative stress theory, aka, and more specifically, the increased iron levels. Next, we have mitochondrial leaking. So mitochondria is the powerhouse of the cell. I think we all know this. And it actually does a lot of things. I mean, it's a powerhouse. Of course, it does a lot of things. And we have one part in the mitochondria called the complex 1 activity. This is one of the many purposes of this. Usually, in patients that have Parkinson's disorder, the complex 1 activity of the mitochondria is reduced. Because of this decrease, adenosine triphosphate, which is can be converted to energy, the production of adenosine triphosphate will also decrease because Remember, mitochondria is the powerhouse of the cell. So if you have one part, one of the purposes, decrease in action, then of course the production of energy could also decrease. This could lead, and also, sorry, additionally, aside from the decrease in energy production, we also have electrons that are able to create energy, are not able to leak out of the cell because of this one complex one having this problem. You see, like you think that's how it affects everything. One part is affected, everything's affected. So it's crazy that how we're all alive right now. So if this specifically, these electrons that can create energy leak out of the cell, that's why we call it mitochondrial leaking. They can also turn into free radicals. Just think of free radicals as antagonists. In an anime, in a show, in a movie, they're the villains. They're harmful. And not the good villains, they're just the bad villains. So next we have this very familiar term, alpha synuclein. So this theory suggests that oxidative stress can cause warping of the forms of alpha synuclein. So what do I associate with alpha synuclein again? Lewy bodies. Remember, I mentioned in the previous video that Lewy bodies are basically abnormal clumps of aggregated alpha synuclein, right? In an oxidative stress theory, because of the amount of stress that occurs, it could lead to misfolding or warping of the forms of this protein. It changes the shape, it changes the form of this protein, also called as misfolding. And once that happens, it would turn into a Lewy body. And a Lewy body again, what is a Lewy body again? It is abnormal clumps of alpha synuclein, and it can affect dopamine neurotransmitters. It can affect signal transmission. So you see how it's all connecting together? It's so crazy, bro. So what happens once they turn into Lewy bodies? Since Lewy bodies is harmful to the signal transmission, it's harmful to the neurotransmitters, they could also damage the mitochondria, the powerhouse. It's being damaged again. And this process repeats. So there's more stress, and it repeats. Because of the stress, there's misfolding. Because of the misfolding, there's stress, right? So oxidative stress leads to warping of the shape of the alpha synuclein. The warping of the alpha synuclein leads to production of Lewy bodies. The production of Lewy bodies can harm neurotransmitters and signal transmission, leading to more stress, and more stress could lead to oxidative stress, and until it reaches apoptosis, which is what's a more safe way to say this before I get flagged by YouTube? I guess solo execution of thyself, of thy cell. The cell commits solo execution, primarily performed by the cell itself. Yes, that's what I mean. So I hope this made sense. Oxidative stress theory can be a bit confusing, so I guess, yeah. So I'm gonna go over it quickly and try to explain it as simple as possible. Oxidative stress theory says that when people age and when people experience chronic diseases, this can cause an increase or accumulation of damage inflicted on their cells. And what causes that damage are the molecules called free radicals, or antagonists of the story. The Fenton reaction describes the role of dopamine here and its byproduct. Hydrogen peroxide is catalyzed by by iron, and in Parkinson's there's increased levels of iron, meaning once hydrogen peroxide is catalyzed, it produces hydroxyl radical, and hydroxyl radical is a antagonist. It's a villain. It's a villain. It's a villain. It's a free radical. It's a villain. It's evil. Evil. Mitochondrial leaking just refers to when there's an activity in the mitochondria that is decreased. When that's decreased, energy production is decreased. When energy production is decreased, there's also decrease in the electrons. I mean, there's also leaking of the electrons that create energy because the complex 1 activity is shutting down and is not working at as efficiently as it could. And once those electrons seep into the matrix, they can also turn into villains, free radicals. Again, we also have alpha synuclein. Stress, misfolding, stress. Oxidative stress causes warping of their shape. Warping of the shape creates Lewy bodies. Creation of Lewy bodies can damage signal transmission and neurotransmitters. Once those are damaged, it causes more stress into the matrix, and that could lead to oxidative stress, and then the cycle continues until the cell commits solo execution performed by the cell itself. Boom. Oh, right. I mentioned glutathione earlier because, yeah, it's an antioxidant. What I mean by antioxidant is it's one of the neutralizers. So remember, this can be neutralized. So if you're a healthy person, if your brain is healthy, your brain can neutralize hydrogen peroxide, meaning it could prevent the production of hydroxyl radical. Hopefully, this theory made sense. I guess if one tip to remember it is simply villains are free radicals. Villains are the free radicals. That's it. That's all you need to remember. All right, I'll see you in the next part. Hasta la vista, baby.